Thank you, Rick, for the introduction. So, yeah, welcome everyone, also from my side. Yeah, at some point, Rick asked me whether I would give a short lecture here on product line economics. And his argument was, well, we don't do it, but students should hear about it. So I guess you don't have a lot of background, but Rick told you or teach you a lot about the technical side of product lines. So in this 1 hour, I basically try to convey some ideas about business aspects, which I think always plays an important role in software engineering. Unfortunately, if you look at textbooks, a lot of research, etc., it's typically underrated, if not to say ignored. And throughout my career, which already spans a few years, as Rick just pointed out, I always found it extremely important to look on the business side of things as well when I was involved with companies. And so I try also in my teaching here at our university in Hildesheim to get this a bit across. You know? In Hildesheim, in the product line lecture, we take several weeks where we go much more in depth. What I will try to do today is mostly give you some points about business and software engineering / product line engineering, things to ponder on a different perspective, perhaps things to ask yourself or ask me in the question part later on. So I'm pretty sure I cannot compress in 1 hour a lot of methodology knowledge. So I constructed this specific lecture to just touch on a lot of topics and give you some ideas and fodder for thought, but not go too deep into things. So the topics we are going to touch in this lecture is basically about this business perspective on software engineering. I will also touch on company strategy, and I try to show with a few examples that how you do product line engineering and whether you do product line engineering depends really on what you want to achieve as a company. I'm sure Rick is not making this mistake, but I've seen it thousands of times in software engineering that people talk about the best method. And I'm a strong believer there is no best method for anything in software engineering. But rather things are context dependent, whether some way of working from the software engineering perspective is a good or bad way. And with the example of product line engineering, I try to bring this a bit across today. I will then also touch on understanding costs and benefits of product line engineering a bit better. We'll very briefly touch the topic of scoping, which basically is about targeting. Where do you focus your reuse investments within a product line? But that is typically a pretty long part of my usual lecture. So I cooked it down to basically 2 slides. And I will round up the lecture basically with going to this question: when definitely not to do product line engineering, or when is it actually a very bad idea to do? So as I already mentioned, this is mostly an overview of topics, of aspects, basically to get in touch with you and to talk together about some things. I will not describe detailed methods because it would just be then too much in this single lecture. If you have any questions during the lecture, of course, you are invited to just post questions also during the time. Otherwise, we also will have some time for questions at the end of the lecture. Rick already introduced me. Here's a short slide on myself as a person. Or as a software engineer, I should basically say. I studied computer science at a university. During that time, having very little contact with businesses, but then I joined Fraunhofer IESE. This is the institute within the Fraunhofer area which addresses software engineering. I worked there for nearly 10 years, and basically also due to that, I got in touch with a lot of companies, because the Fraunhofer model is you basically do applied research, and applied research is characterized by whenever you do research, you do it together with companies, basically. So I had the opportunity to get an inside look on many big and small companies, some well-known, some niche players, and that also influenced my thinking. But another important influence on my thinking was also that I was always interested in the business side. So I'm not an economist or something like that, and I'm not an active researcher, I would say, for myself on business or software business. I mean, there are people who are really focusing on that, but I was always wondering, why is it that some companies are doing good software engineering and they just die, and other companies are doing lousy job but they survive or even flourish? Why is it that or what brings the history of different companies, and how does that influence how they actually work and how they become successful from a business side? So always this interaction between technology on the one hand and the business aspects on the other hand, that actually goes back all the time when I started with programming as a school kid, when I read about the very first days of Apple or other stories. So I was always interested in that. As Rick said, I worked a lot in product line engineering. That's roughly now 25 years. I did my PhD in an area which is at this borderline of business economics / product line engineering, which was product line scoping. I then became a professor of software engineering, and I was always involved with the software product line community, was their general chair, was steering committee member, chair of the steering committee for the software product lines. Actually, in our current research at my group here in Hildesheim, we are not doing so much on the economic side. There are reasons for that, which then goes into research strategy stuff, but it's always something I'm on the lookout for. And I'm also every now and then doing some consulting when I go to companies, just to keep in touch how they work and how that influences how they do product line engineering or other aspects of software engineering. And I would like to, I hope I get some of these experiences across today. So major talking point I already showed to you. So good software engineering is not company success. I mean, you will hear a lot of people telling you, and now I hope, Rick, I'm not getting too close. You did not tell your students that good software engineering is directly leading to company success. No, it isn't. No? I mean, being good at software engineering can be an enabler, but if we talk about company success, it's ultimately a game of costs and revenue. And if we want to understand how product lines are connected to company success, which it is, we need to understand what are cost impacts and revenue impacts of product line engineering. And this will be the major driver for this talk. I will start with looking at the cost side, which is actually the more common perspective, because I think it's also easier to deal with. But I also try to shed a bit of light on the revenue perspective, which if people in product line engineering often talk about, just is about, yeah, you can do more products. But I would not say this is the full story. of the revenue perspective. So this is definitely an overly simplistic view on the topic, but it should be sufficient for a starting point during the following 1 hour, roughly. Okay, that's something. Well, so if people talk about product line engineering and the cost perspective, then they typically use a picture like this one, which says, okay, if I'm not doing reuse, then I'm using a traditional development approach, then roughly the total amount of effort is proportional to the number of products I deliver. Because you have experience in developing software, I suppose you understand this is a very high level abstraction. Of course, the total effort depends on what is your learning experience. It depends on how big the products are and so on. But roughly, if you do not directly reuse code, you develop more products. Basically, in proportion, your effort goes up. Effort is the key story if we talk about costs in software. This is also different from other domains, other engineering disciplines. In software engineering, or in general, in computer science, the cost of the people doing the development is the core driver, basically always. In classical engineering disciplines, it very much depends. I mean, if you are working in mechanical engineering, setting up a production site or doing or really producing something, it has enormous physical costs. And then sometimes the total effort that engineers spend on creating something is just an afterthought. It's just a smaller part of the total costs. Yeah? In software engineering, it's totally different. Production is basically free of software. It's just copying. All that counts is effort. That's why we are always talking about effort if we are interested in costs in a computer science context. The idea now with product line engineering is on the surface very trivial. It's saying, well, we try to set up something where we do an initial investment and create some reusable components. And then when we actually develop our products, we reuse these components. And that means we save in terms of total cost. If we do that really in this extreme way, we first invest more or less a lot, create an infrastructure, and then just develop products. That's often called a Big Bang product line development. And the Big Bang is basically this explosion that is here set up with the initial investment. Of course, this is, there are reasons to do it that way, and there are reasons not to do it that way. The reasons to do it that way are pretty clear. It gives me a lot of benefit here, and that is basically shown here as this green triangle. So that is basically effort saved or cost reduction. It gives me a break even because the lines are crossing here. This break even is typically around 2 to 5 in typical studies. People often use a reference value of 3 products that I need to do a payoff. So that's basically the most efficient you can get. And therefore, the obvious question would be, well, is Big Bang approach the best way of introducing your product line? And the answer is, well, there's one issue. The issue is, what if my initial investment is wrong? Because in business, there are actually 3 sides, not just 2. There's not just cost and benefit or return. There's also the risk involved. And the Big Bang is a high risk approach. So What people sometimes do in that instead is basically an incremental product line setup. You could basically start with doing your first prototype, then, or your first product, I should say, because you actually deliver it to your customer. Then you invest a bit in reuse. You are therefore a bit more efficient with your second product. You take this to invest again a bit, and so on. And what you see is, well, this is a different approach. You get ultimately more or less to the same point, but at a much later break-even point. So you are paying for your risk control in some sense. But still, that may be a good thing to do from a business point of view. So the incremental approach helps you to address risks by catering for agility, but in total, it's less efficient. It also is sometimes useful from the perspective that I can deliver a first product early. Time to market often matters or may matter to customers. And if I can start basically with developing of a first product right away, then this helps me in terms of avoiding time to market problems and missed revenue or missed customers that I would be serving. There are also, besides this later break even, there are also other disadvantages to an incremental adoption model. For example, as part of your creation of the first product, you're going to create an architecture. This architecture will automatically be more strongly influenced by your first customer than it will be by later. So actually, there may be additional refactoring costs and even other problems later on that appear due to this incremental approach. So it's really about finding a trade-off, whether incremental or big bang approach is a better way to do things. Let me give you two examples. These are actually two long-standing companies with which I had the opportunity to work actually very early on, and then at later points in time also to revisit them and see what came out of their product line development in each case. So the first one I would like to briefly illustrate is Maxess Systemhaus. Today, this was acquired by the Bison company, which is a Swiss company and is part now of Bison Deutschland company. So this company was set up in 1996 with a specific task. It was actually set up as an IT part of a company which basically sells everyday goods. So it's now I'm missing the names of all these chains in Austria, I'm afraid. So in Germany, it would be like Aldi and other supermarket chains. So this was a company which ran a chain of supermarkets, not a really big one, and they said, okay, we can, by better software, become better as a competitor relative to the other companies. So they did set up this company to develop their own IT solution, their own inventory management system for a large warehouse. It was an all new development team. There was little experience at that time with these kind of systems. So they tried to hire a few analysts who had some background, but all the development team was basically completely new to the domain. So there was very little to say. That started with basically the inventory for a large distribution center. Then the company ran further warehouses, further distribution centers. So then they built IT solutions for those as well. So that was completely within the same company. Then they moved on to joint venture companies and so on. And at that point, there's also, I think, interesting from a business perspective. At that point, something changed because the company basically had to be spin off. Yeah? Nobody is going to buy an inventory management system from a company 100% owned by your competitor. Yeah? You just don't do it. Yeah? So at that point, this company became an independent company, so it could be competitive on the market and actually enlarge its product lines. But the idea that ultimately it would be about product line management was there from the very first beginning. But at the beginning, it was really the focus, now let's get this product out of the door, and then we move on from there. So it was really a prototypical incremental adoption approach that they used. These are screenshots from their application, and I asked them for screenshots from basically two variants of the very same part of the system. And you may see that if you look at these two screenshots, that they are very similar in the sense that basically the fields and so which you have here on the top, and if you look here at this middle part and so on, it's the same stuff. Yeah? There's actually ultimately the same code behind it, but there are other panels as well, which you have here in the second variant, and they are related to the differences in the domain. So for example, this is a system for typical living goods. Goods that like food, drinks, and so on, they are heavy rotation goods. So people deal with these goods on an everyday basis. So they don't need much additional information. And this one is from a system which are slow rotating goods. Like you see it here with the picture, it's a part of a motorcycle. And it's a company who does such inventories for motorcycle. But if a customer comes in the door, then this part, they didn't deal with it for weeks or months, perhaps. So they need much more information. That's why even on a UI interface level, these systems are somewhat different. So you can really see, in some sense, the variability in the UIs in this case. Yeah? But this was created in incremental adoption approach. A second product line I was involved with comes from a company which actually is quite opposite. It had already, when they decided to start this product line, they had already a lot of experience in finance information system, which was the domain of the new system. This company was created in the late 80s. They had very good contacts in banking for many, many years. And then in end of the 90s, they said, well, this web thing is coming up. So it might be interesting to create a new product line for web-based financial information system. And what they did was they decided, okay, basically all our current personnel is fully booked. It has no experience with web technologies. We set up a new group for this new product line. But this group is going to be small because we are a small company. We don't have an arbitrary amount of money. And there are much larger competitors. And they were thinking about a risk. And that goes to this question of time to market versus revenue. They saw the risk that if today they build a product, make it known in the marketplace, that under those circumstances, the big competitors would rush in and with their superior manpower would basically take the market from them. So they decided at the very moment we make it known to anyone that we are doing these kind of systems and that it is worth it, we have to be able to satisfy each and every customer demand. And really, really fast. So they were not worried about the lead time, the time it needs from start of the effort to shipping the first product, but they were very much worried about the time it takes. If you have a first product on the market, what's the next and the next and the next product? How long does that take? Yeah, so these both some sort of time to market issues, but very, very different ones. And with this setup, the Big Bang adoption is actually the less risky approach. Yeah? While the business constraints in the first case pushed them to an incremental adoption case, here it pushes them to a case where they really wanted to do a Big Bang adoption because in some sense it was less risk. Yeah? The question is, why did they think it was possible? Because there were risks involved. They thought it is possible because they had 10 years of experience with their prospective customers. No? So they knew they would be able to basically contact the right people, understand how those people think, what are the relevant requirements, and still do everything in a stealth mode. Yeah. So this company is called Market Maker Software, or was called at that point in time. Now it's a subsidiary of the VWD, the Vereinigte Wirtschaftsdienste in Germany, which is a conglomerate of financial information system companies. Yeah. Again, just to give you an idea, these are two different screenshots which illustrate the diversity of systems they built. So this would be, for example, for a banking application, you are talking with somebody who gives you a recommendation for what to do with your money, and they would pull up pages like those to first get themselves the necessary information and then also show this information to their customer. This would be this first case. The second case, from the same kind of financial information system product line, they got, or this is more a trader place, yeah, and the trader wants to have overview of a lot of different assets at the same time, as opposed to the other case where you want to have one asset at a time. Yeah. In this case, I also know about their reuse level, which basically characterizes how high is the percentage of components you reuse as opposed to components that you build anew. And they achieved reuse levels of about 95, which is really top industry values, meaning 95% of their products were created from reusable assets. Only 5% had to build on average, specifically for individual customers. And of course, that meant they could be extremely fast. Depending, of course, what the customers want, but it was really fast. Like they had cases where they needed like 3 days from the customer order to installing the system on the customer side, basically. Yeah? And still it was a tailored system. If we think about costs, it might also be interesting to understand where do the costs come from. So what are the influential factors of costs? And there are typically 4 constituents if you think about costs in a product line setting. These are the 4 fields here on the slide. So our first constituent is organizational costs. All these kind of costs that are involved with adapting as an organization to a product line approach, as opposed to whatever you were doing before. This includes costs for personnel training. It includes cost for buying tools and so on. It may also include some sort of refactoring efforts to some extent if you need to do some things with your code first. So this would be the adaptation costs. Then there is this build support, core asset base cost, all the costs involved with creating assets that you can effectively reuse, or code, or it could be code, but it can, of course, also it's architectural documents, it's requirements documents, and so on. Then, if we have these reusable assets, we also want to reuse them. This is often told as, well, I just check a box and then I have it. Well, in reality, it's not always that easy. So there may be a more or less non-trivial cost involved with this reuse, depending on the specifics of the approach that people are using. And you not always have a situation that you just have to check boxes, for example. Then we have here also the cost for building product-specific parts. This is the last constituent, because even if you have a product line which is up and running, individual customers may want, or typically will want, some functionality that is specific to them, or some adaptation which is specific to them. In some sense, you saw that on this slide. For example, they had the problem, each and every customer wanted to have, or did want to have, their specific UI layout. They always had an idea how it should look like, so that each and every time was tailor-made for the customer, while other components, of course, were simply reused. If you have all these cost constituents, you can basically, with a formula like that, you can basically sum up your costs. What you will observe, these costs are still parameterized, and you still have to estimate these individual costs. Like, for example, how much, so for example, this is to read C unique of PI would be how much does it cost to develop the unique parts of product I. This would give us a cost, and then, for example, we can build cost models which compare building products with product line engineering versus building products without product line engineering. If you go deeper into that, we come to return on investment analysis, which is which ROI stands for, which is basically pretty trivial. If I now invest in product line engineering, what is my benefit like 5 years down the road? And DCF stands for discounted cash flow, because if I'm looking at something 5 years down the road, we all recently hear a lot about in the news about inflation picking up. So money in 5 years time has not the same value than it has today. That is the idea of such discounted cash flow analysis, where I basically depreciate money according to the time when I invested or when I get it back. And then sometimes I get rather different results in a discounted cash flow analysis than in a pure ROI analysis. And of course, the more precise one is actually the discounted cash flow analysis. So this was a short outline of aspects going into the question of what does it cost and how much cost do I save in a product line engineering situation. What I now want to go into is to discuss a bit deeper the revenue side of things. And in order to do so, I think there are a few terms that we need to look at in order to get a better understanding of companies. And I always made the experience, one aspect which is very important is a distinction between market-driven and customer-driven, because a lot of other factors derive from that. If a company works in a, and typically companies have one of these two modes. I have still to see any company which is good or equally good at both modes. And typically it's really, they do either or and just don't mix it up, except for what I have here under number C. So let me start with what is market-driven. Market-driven means I create standardized products. These products aim at specific market segments, which I, in the beginning, imagine that they are there. And then basically I build the standardized products and I hope I really made a sweet spot of my market. So that is a market-driven mode of operation. Basically, all the consumer companies work in this mode because it's just not a feasible business model to say, well, for customer X on the street, I tailor something for your needs. Because just creating the specific system will be completely overblown relative to what you can earn from this customer. The customer-driven approach is a different one. There, I have basically one product per customer. Huge industries work on that in this manner. If you think about the two examples I just gave you, the merchandise inventory systems and the financial information systems, they both work in this way. They basically created specifically for individual customers solutions. And in that sense, these are customer driven. This also shows there's no conflict between being customer driven and being or using product lines, which is sometimes not obvious for people in my experience, because some say, oh, we always build something specifically, so we are not in a product line. Well, quite to the contrary, it's actually more beneficial for these customer-driven companies because they have a much higher rate of variance. And because of the number of products I ship and basically how much I save per product, actually they can save much more with a product line approach than a purely market-driven company, which often has like 5 or 7 or 10 products. That's then, it's enough to benefit, but it's not this enormous benefit. What you also very often see, and I would say it's today more common than 20, 30 years ago, that companies combine both. They say, okay, I'm offering a specific product to a market, but then each individual installation that a customer wants is then tailored to these specific needs. So in that sense, these standardized products are not really standardized. They are just big collectors for everything within a specific area that customers want. But they still also define boundaries of applicability. So depending on how a company is set up, this already has some implications for what it can benefit for product lines. The first is, of course, the number of products, which heavily influence any calculation. The second is, if I'm in a customer-driven mode, the revenue scales linearly with products. Each customer orders individually, pays individually. I get this money. If I'm more efficient, I earn more. In a market-driven mode, on the other side, additional products lead to diminishing returns. That may not be obvious, But the idea behind that is if I'm cranking out a larger set of different products, then ultimately they will compete for the customer attention. And that means, or that is basically called product line cannibalization. They will actually compete for the same market. So I'm not only competing with competitors, I'm competing with myself. And that means with more and more products in my product line, I'm basically getting diminishing returns. And that's why, in that case, it's less of interest to do product line engineering. So another concept, another point that I would like to get across is people often talk about product line engineering in the sense of these marketed product lines. Yeah? You have a banner in a company or an ad for a specific product. And the question is then, how does product line engineering help me to create these products? And my experience also with industrial partners is this is an error in thinking, and it's a difficult error to get out of the people. So they are so used to combine product lines, the term product line, with these marketed product lines, basically this stuff they have leaflets for, that they typically identify both. And that's why I typically differentiate a marketed product line and an engineered product line, because this marketed product line is fundamentally can be fundamentally very different. So if in the marketed product line, the individual products do not need to have any connection at all, full stop. So in Germany, we have this Wieso product series. That's actually one company which brands different products with this Wieso label, which is at the same time a German TV show for economics. And each individual product in this marketed product line comes from a different company. There are no two products that really have the same background. And that is the difference to an engineered product line. The engineered product line is really the set of products that you engineer together or can engineer together. And that is basically independent of the marketing, and it's independent in both ways. So you can have something in the engineered product line which is not in your marketed product line. So for example, all these companies who provide such Wieso products, they have typically their own product line, and then they engineer from the same assets, meaning in the same engineered product line, they have a product which actually goes into this Wieso branded, marketed product line and not in their own product line. So this is important to really differentiate. Is the scope of the product line we are talking about really a good engineering scope, or is it just a marketing scope, which may be a starting point, but may ultimately be a very bad focus for product line engineering? For example, if you look at the current series of, or the current Microsoft Office products, they have all these classical desktop versions of the products, and they have the browser-based versions of the products. I have to admit, I'm not an expert on these systems, and especially not on how Microsoft is building them, but I would actually be rather surprised if the desktop version and the browser version is part of the same engineered product lines. But obviously, it's marketed as as one whole product line, because that's how they want to make it appear to the customer side. So getting this differentiation right, and then really understanding what is a good scope for an engineered product line is a very important thing. There are also other special cases I'm typically discussing, but I won't go into detail here for lack of time, which is, for example, hierarchical product lines. So there might be hierarchical structures in this overall construct of product lines that I'm engineering. A typical example would be, I have a, for example, Philips built its video recorders, and Philips built its TVs, and they both were different engineered product lines, but they also had some components which were joining them, like tuner software. And so you had a hierarchy where you have basically a tuner product line. It delivers versions to this TV product line on the one hand, and on the recorder product line on the other hand, and then these build complete new product lines from them. So this or these are more complex situations of product line engineering. It's also worthwhile to look at the topic of market strategies and how do they relate to product line engineering. What you have here is a list of different strategies that people or that companies typically follow. I used to join the list from 2 different books to create this one. So it's from Porter on the one hand and Kotler-Bliemel on the other hand. And this joint list, basically, I can ask for each strategy that a company has, is product line engineering good or bad relative to this strategy? So it is really helping me or not? Or is it perhaps even disadvantages? And for cost leadership, I think it's pretty clear. That's typically positive interaction between both. For differentiation, which basically means, I should say a few words on the strategy. So cost leadership is a strategy to say, okay, we build most of the similar products like others, but you get it cheaper with us. So if you follow a product line engineering approach, then of course there's a positive contribution by product line engineering because it helps you to produce cheaper. Differentiation is something different. Differentiation is the products of the company differ by a certain aspect. And that can be many things. That can be a service that is included. It can be the brand name that they have. It may also be specific functionalities and so on. And depending on the kind of differentiation you're looking at, it may be positive. But I would always be very reluctant. So you cannot say there's a strict one-to-one contribution of product line engineering to such a company strategy. Then there is focusing. That's basically, I'm saying I'm doing a specific niche in the overall market better than other competitors. For example, the one I mentioned with the warehouse management system, they basically said, well, in this specific area, warehouse management for supermarkets, we are highly specialized. We're building the best products. And in some sense, that helps you also then to build a product line engine because your focus in the company strategy allows you to more tightly scope what is your functionality and therefore what is the scope of my product line. Then there's the strategy faster. I'm bringing new products to the market faster. And there's actually a word missing here, so it should be PLE is initially negative because of the lead time you need for setting up something. Later on, of course, time to market contribution is positive by such a product line approach. So if you want to understand whether product line engineering is something good for a company, you basically need to understand these questions about the company's strategy and positioning to answer whether it is good and where is the true contribution. Just saying, oh, it's reducing costs, maybe not as important to a company as you may expect. You can also ask, do it the other way around and ask companies, why do you do product line engineering? What is it you get out of it? And then the answers range in various dimensions. You have, of course, the development effort that is reduced. You have time to market improvements. The time to close customer issues remain constant. I should explain that. The idea behind that is, if I have a customer issue, something doesn't work, a bug, so to speak, then I do not need to maintain 100 versions of products to really remove this bug from all of my delivered products, but rather I can fix it once in the overall asset base and then just ship new versions to all my customers. Yeah? So that reduces the effort, and my time for closing customer issues is not growing linearly, which would be the case in the other situation. You know? I can achieve higher product quality because I'm reusing well-used components where I know they already have a high quality. One case I found particularly interesting was they built product lines for none of the above. They moved into product line engineering to standardize user interfaces across a very complex product suite. And people had to work with all of these individual products and therefore valued consistency of the user interfaces rather highly. And in some sense, the easiest way to get a consistent user interface across a set of products is it's the same components that implement these user interfaces. You know? If you really build these structural and semantic issues into these components, then you quote unquote get standardization for free. You know? Other benefits companies thought were address labor shortages, for example, or decrease the time for certification of a product simply by certifying some things once and then reusing, including the certification. That's also very context dependent because it depends on what certification means for a specific product. There are cases where you cannot reuse certifications, and then that is not giving you a benefit from product line engineering. Another aspect which is sometimes discussed in the context of product line engineering is what would be technically called an option value, meaning you increase flexibility by creating a product line and therefore can delay commitments to specific versions. If you look at that from a financial perspective, it's actually, you would describe that as an option, as a similar to financial options, basically. So you may have noticed I didn't tell you anything about, what does it actually mean for revenue? That has many reasons. First off is it's really very, very dependent on a specific case in a company. The other is it's even in more dimensions context dependent, because even if I can say something about effort that I'm saving, it's not trivial to deduce the time to market improvement for that. And if I have a time to market improvement, how much would that, for example, improve my revenue is, to the very least, messy and difficult to really describe. So the first part, relation between effort and time to market, that is not a one-to-one. Why? It depends on the overall project pressure I have in the organization. So if I have enough people, then actually, if I increase effort, my time to market will not increase proportionally, but will increase sub-proportionally. On the other hand, if I'm suddenly getting another project and all the people need to go to the other project, then even a small increase in effort may lead to very large increases in time to market. The other aspect is, even if I would know time to market impact, it would only help me a little bit. Because if we look at innovative markets, they are characterized by revenue decay curve. Meaning, if I'm very early on the market, I get a lot of revenue, and that goes down very, very steeply. You have that in certain domains, for example, in hardware, but it's similar in software to some degree. Yeah, for example, in the if I have a newly defined market, and then there's typically a market window which is rather short, where competitors have to enter the market as well. Otherwise, they will have a huge disadvantage over the perceived market leader. So if I take a fixed delay, then the revenue impact is, if I'm entering very early, it's actually pretty large. But the same amount of delay, if I'm entering late, only leads, first of all, to much smaller revenue, but it also leads to a much smaller delta in terms of the revenue. So this basically gives you a lot of variables which you cannot fully control, and typically people argue then on a qualitative perspective. That, of course, is not as difficult in a mature market. There, a certain delay is typically also reflected in a corresponding reduction of revenue. But as I said, if you have questions or something, you can also ask in between. Another point I would like to touch at is the issue of scoping. So far, we mostly focused on the big picture things. How is cost impacted by product line engineering? How is revenue on a total company perspective impacted by revenue, and so on? But if you know you want to do product line engineering, that's not the end of the story. There's still the question, how much product line engineering do I do? What do I really invest in reuse, and where do I invest in reuse? Which components to create for reuse, and which parts of the system perhaps to develop as one-off? As I mentioned with these financial information systems, they had 95% of reuse, and they never even tried to be at 100% because they understood the final 5% are not worth it. They would, for example, involve these user interface aspects, and they were always, or it was always easier for them to just team up somebody who made this user interface design. The customer was extremely happy because it was their solution, and it was not a big part of their costs at the end of the day. So these kind of things also play a role, and that is, so to speak, product line economics in a more microscopic view. It actually is connected to what we discussed so far, to the marketed product line, because scoping, which is about bounding what you make for reuse, begins on the level of the product portfolio. And it's therefore also strongly related to what marketing people call a product portfolio management. But it's really product portfolio management for the engineered product line. Therefore, the concrete product portfolio may be profoundly different. There are techniques for that. I will, as I already mentioned earlier, I will not have the time to go into details on that. Then you typically zoom in. You ask what parts of my products are of interest for reuse. That's where you should be able to find things like, okay, my user interface, it will not work. Yeah, don't waste any effort on these kind of things. But my charting, my alerts, my financial information inflow, these are great areas for reusable assets. So this is basically the domain scoping part. And ultimately, you can also do asset scoping in the sense, what are the concrete components we are going to build? Good. These scoping methods are typically strongly manual, in the sense that they are methods, meaning there's guidance to do them, there are process descriptions, there are checklists, there are interview guidelines. I mean, I mentioned I did my PhD in this area, so there's really hardcore material with repeatable methods, but there is not a tool where you just put in, you just push some buttons and then you get the results, but because you need to deal with all this domain knowledge in a structured manner. So it's similar to other assessment methods. If you perhaps know these kind of methods like the process assessments, CMMI or SPICE assessments, they have similar characteristics. What influences such scoping decisions is a wide range of different aspects. Here are the ones that I use for domain scoping. These are questions like, is this area we are looking at, is it mature enough? Do we understand it well? If we don't understand it, investment will probably not pay off because we cannot well develop reusable assets. Is it stable enough? What are the organizational constraints that we have? Do we have enough resources? All of that influences from a practical point of view, where we will be able to do a product line effort or supported product line effort in a specific part of a larger product line. Then things like market potential, commonality variabilities, and so on, what you have here under benefit dimensions, these are different aspects that you would like to look into in order to understand if I'm doing reuse and I invest in reuse, do I get enough out of that? That's what I wanted to give you as a very rough idea, obviously, for scoping. I will leave it with these two slides. Actually, if you ask my students, we do 2 lectures on scoping. So I'm obviously have to cut it short here because I'm still would like to touch a final topic, and I'm already running a bit late. And that is the promise when not to do PLE. I mean, that's actually a question which is bugging me for quite some time, is because often product line engineering is sold, like many other software engineering techniques, as a panacea. Just use it and you will be fine. And the question is, can it even be the other way around? Can it be detrimental to what you are doing as a company? And perhaps be obviously not helping, but even more, that you actually have a negative impact with it. So we already heard about diminishing returns of variation, but the thesis I want to talk to you now about is variability can be just bad. if you try to create variability, if you try to support variability, you are already in the midst of the problem. And what I want to tell you now is a tale, so to speak, of two companies. And the incidents are already some years back, so probably you do not know them at least firsthand. So let me recap. The first company was Nokia. In the late 90s and the early 2000s, Nokia was the mobile phone company worldwide. It was firstly admired for the usability of its phone. So that was really critical knowledge, how they did that. And it was extremely competent in PLE. I worked with them on some international projects, and the people really knew what they were doing. It was already in core research, they had like 20 people all clustered around the topic of product line engineering. And that was only the research people who then tried to bring this knowledge to all the business units within the company. So that was really a major thing. And they managed to create hundreds of product versions per year for different regions, different functionality, different customer groups. They were segmenting their markets back and forth and really creating an extremely well accepted offering to the market. They even had things like an app store, they had touch control, they had smartphone capabilities in the sense of specific apps and so on. Even web browsers in their smartphones, but all of that in different phones because they had a lot of variability. They offered programming interfaces. Back in the day with my groups, we tried to do some mobile programming and it was a nightmare. No two phones offered the same set of interfaces. The interfaces often was obviously not well used because some we couldn't get to work at all in a reliable way, and nobody seemed really to bother about that. At this time, really each and every mobile phone was more or less an handcrafted, no, it was not handcrafted, it was derived from product, but each of them had widely different features. It was sometimes small details that changed from one system to the next, like if you output a string and you are not filling the line, do you have a line feed, a line forward immediately or only when you output the next characters? These very fundamental details were different. So I knew companies that made it a business to enable applications to work on multiple phones. So I know one which actually was also where I studied, situated. They tried to get an eBay app to run on several hundred phones, and eBay turned to their knowledge to get it work. And the way they did it was basically they built a complete interaction layer, an abstract interpreter on top of the phone software to reliably make different products on. And so the idea at that time was really phones were thought of as products. They were not product platforms, they were not core of an ecosystem. And also for that reason, developers were not regarded as an important stakeholder in such an ecosystem because there was not much of an ecosystem. There was a phone company which sold phones, and there were the mobile company which basically provided networks, and that's it. That was the ecosystem at the time. And then a paradigm shift came around, and that basically changed things very fundamentally. This paradigm shift was was basically the iPhone 1. And what Apple did was the absolute opposite of the business strategy that Nokia had at the time. They had exactly one model at a time. They were creating a new product. The iPhone 2 came out like a year later or so. And at the very same day, they stopped selling the iPhone 1. So it was, from a developer perspective, you create an application once, and it immediately runs on 1 million mobile phones. And developers hate variability. They hate it if they need to take care of specifics of individual systems just to address a large user group, because that is unproductive work. And I mean, a lot has been written about the paradigm shift of the smartphones. In my personal view, this was basically the most fundamental aspect of this shift, which most people did not realize at that time, that with the advent of iPhones, suddenly mobile phones became a compute platform and the core of an ecosystem with very, very different requirements, and not just a wild set of products. The results are widely known. In January 2007, the first iPhone came out. Nokia had about 50% of the worldwide market. 5 years later, Nokia was below 3% worldwide. So it was a complete disaster, a complete destruction when this new paradigm arrived. And this paradigm is not a product line paradigm. What made Nokia successful, its extreme competence in market segmentation and defining new variants, etc., being great at product line engineering. This all just stood in the way of becoming or staying successful in a completely shifting market. Because if you are talking now about platforms, which are core as an ecosystem, all variability is bad. You just don't want it. So development partners in an ecosystem really value if they can develop it once and then it runs everywhere and not take into account a lot of peculiarities. Even the users value it in some sense. That's why people stay with Windows. You basically stay with the platform they're always using, because you learned it. This wasn't a personal investment. You stay with it because otherwise you are wasting some of your work. So that is just another aspect where variability may also be bad. So, but in general, I would say really in ecosystems like this one, explicit variability is disadvantageous. There may be cases where you need to do variability. I mean, we are right now in the process of creating a platform for Industry 4.0 systems. We have to deal with variability, but we make it then a big effort also to hide this variability or to support it by tools that allow people basically to generate code that basically glitches over this variability that is involved. In the chat, somebody already mentioned Android, and it's a perfect point. So Android as an ecosystem, initially they just had the same problem. They allowed for a lot of variability. In some sense, they had it because for that business model to work, they need other companies to be willing to produce different phones, and these companies in turn want to set themselves apart from each other. So that was a huge variability driver, but from an ecosystem perspective, it's actually disadvantageous. But my observation is from generation to generation of the Android platform, they try to claw it back and reduce the amount of variability that is exposed to the developers, because you don't want variability in product lines, variability in ecosystem platforms. Yeah? And you really want to reduce it to a minimum. Good. Yeah, therefore, if your business model of your ecosystem requires platform variability, try to hide it, provide tools to cope with it, etc. Yeah. So that's my message. It depends on what you're doing, whether product line engineering, what are benefits for product line engineering, whether you have benefits or disadvantages, aspects of product line engineering in the first place. And to me, it's really part of a larger topic, namely the topic that software engineering is really about a large toolbox, and product line is just one set in this toolbox. And understanding when each of these tools can be used beneficially means you have to understand the business context in which you are going to apply it and what makes this important. Because if you're not able to do that, that's just as bad as if you're not able to do the technology in the first place. So with that, thank you for your attention, and I hope we have some time for questions and a few questions.
Thank you very much, Klaus. Yes, we have time for a few questions. First, you get an applause. It's a bit tricky, hybrid settings, but still. Also stop the recording.